Let's look at the next problem of indices, which says under root 1 upon 4 plus 0.01 to the power minus 1 upon 2 minus 27 to the power 2 upon 3. Now obviously it is 1 upon 4 to the power 1 upon 2 plus if I take away the decimal 0.01, if I want to remove the decimal, then upon 100 to the power minus 1 upon 2 minus 27 is 3 to the power 2 to the power 2 upon 3. This is 2 to the power minus 2 to the power 1 upon 2. This is 1 upon 100 means 10 to the power minus 2 to the power minus 1 upon 2 minus 3 to the power 2 into 1, 2 upon 3. What we have done is 4 we have written as 2 to the power 2 in the denominator. When we take it to the numerator, it becomes 2 to the power minus 2. So power to the power will get multiplied. We have removed the decimal from here, so it will become 1 upon 100. It will become 1 upon 100, or it will become 1 upon 10 to the power 2. When I take 10 to the power 2 from denominator to numerator, it changes to 10 to the power minus 2 to the power minus 1 upon 2 minus 3 3 to the power 2 into 2 to the power 3. So powers get multiplied. 2 to the power minus 2 into 1 upon 2 plus 10 to the power minus 2 into minus 1 upon 2 minus 3 to the power 3, it is not 3 to the power 3, it should be 27, it is 3 to the power 3 into 2 upon 3. Power will cancel. Here it will become 2 to the power minus 1, it will become 10 to the power plus 1 because minus plus 1 and minus 3 to the power 2. So it is 1 upon 2 plus 10 minus 9. 10 minus 9 is 1 and a half. It is 1 and a half. The answer is 1 and a half because 10, 3 to the power 2 is 9, 10 minus 9 is 1, 1 plus half will become 1 and a half. So the complete question is solved here. 1 upon 4 under root I have written as 1 upon 4 to the power half. 0.01 I have removed the decimal and I have brought it 1 upon 100 to the power minus 1 upon 2. 27 is 3 to the power 3 to the power 2 upon 3. Now this in the denominator is 2 to the power 2. When I bring it to the numerator, it becomes 2 to the power minus 2 to the power half. Plus 100 is 10 to the power 2. When I take it to the numerator, it becomes 10 to the power minus 2 to the power minus 1 upon 2 minus 3 to the power 3 into 2 upon 3. So power into this cancels here. You get 2 to the power minus 1 plus 10 to the power 1 minus 3 to the power 2, which is 10. It will become 1 upon 2 plus 10 minus 9. So 10 minus 9 is 1 and 1 plus 1 upon 2 will give you 1 and a half. So this solves your question number 8. Now let us see question number 9. In question number 9 I have 5 to the power n plus 2 minus 6, 5 to the power n plus 1 upon 13 into 5 to the power n minus 2, 5 to the power n plus 1. There's nothing to worry about these 5 to the power n plus 2 or 5 to the power n plus 1. You know the first law is the product law. If I have, suppose, 5 to the power n into 5 to the power 2. Bases are same, so powers will get added. So it will become what? 5 to the power n plus 2. Or if I have 5 to the power n, 5 to the power 1, it will become 5 to the power n plus 1. If I can go from left to the right, I can come from the right to the left. If I have added them, 5 to the power n and 5 to the power 2 is 5 to the power n plus 2, I can break them up also and write as 5 to the power n, 5 to the power 2. That is what exactly I am going to do here. Like in the next step, I'll write 5 to the power n, 5 to the power 2 minus 6, 5 to the power n, 5 to the power 1. This was joined here. I have broken it up now into two parts. Similarly, 13, 5 to the power n minus 2, 5 to the power n, 5 to the power 1. Instead of adding them, like here, when the bases were same, we were adding the powers. If the base is same and powers is plus, so I can break that power as 5 to the power n into 5 to the power 2. Why did I do that? Because now I can take 5 to the power n common in numerator. I can take 5 to the power n common in numerator. It will become 5 to the power 2, which is 25 and minus 30. 6 5s are 30 upon 5 to the power n can be taken out common here also in the denominator. It will become 13 minus 10. Because 5 to the power n is here, 5 to the power n is here. I've taken it out common. It is 13 minus 2 5s are 10. So 5 to the power n, 5 to the power n will cancel from denominator and numerator. You will get minus 5. 25 minus 30 is minus 5 and 13 minus 10 is 3. So minus 5 upon 3 will be your answer. Please see it once again. 5 to the power n plus 2 minus 6 into 5 to the power n plus 1. 13 5 to the power n minus 2 5 to the power n plus 1. So what I've done is I've broken up 5 to the power n plus 2 as 5 to the power n, 5 to the power 2. 5 to the power n plus 1 I have broken up as 5 to the power n, 5 to the power 1 upon 13 5 to the power n minus 2 5 to the power n plus 1 I have broken up as 5 to the power n and 5 to the power 1. What we do is we take out 5 to the power n common in the numerator and in the bracket 5 to the power 2 is left, which is 25. 6 into 5 will be 30. Similarly, I have taken 5 to the power n common in the denominator and inside it will be left 13 minus 2 5s are 10. 5 to the power n from the numerator cancels with 5 to the power n in denominator. 25 minus 30 is minus 5 and 13 minus 10 is 3. So minus 5 upon 3 will be your final answer for the question number 9. Now let us see question number 10. X to the power n upon x to the power n to the power n plus n. X to the power n upon x to the power l to the power n plus l. Then x to the power l upon x to the power m to the power l plus m. We have to prove it. We have to solve it. Let us solve it. How are we going to solve it? It is x to the power m upon x to the power n. I'll take x to the power n from denominator to numerator. What will happen? X to the power m, x to the power minus n to the power n plus n. We have taken from the denominator to numerator, so the sign of the power or index changes. Similarly, x to the power n, x to the power minus l, n plus l, into x to the power l, x to the power minus m, l plus n. When we combine these together, according to the product law, it will become x to the power m minus n to the power m plus n. X to the power n minus L to the power n plus L into x to the power L minus m to the power n plus m. Now the next step, power to the power gets multiplied. According to the power law, if there is power and then again to the power, then powers get multiplied. So it will be x to the power m minus n into n plus n, x to the power n minus n into n plus n into x to the power L minus m into L plus n. A minus b into a plus b, a minus b into a plus b, a minus b into a plus b. You know, when we multiplied a square minus b square as factor a minus b, a plus b. So when we multiply a minus b into a plus b, we get answer as a square minus b square, which we have done in expansions. X to the power m square minus n square into x to the power n square minus l square into x to the power n square minus m square. That will become x to the power m square minus n square plus n square minus l square plus l square minus n square. Base is the same, powers get added. M square minus n square plus n square minus l square plus l square minus m square. M square plus m square minus n square minus n square plus and l square minus l square plus. So x to the power 0. Any non-zero number risen to power 0 is 1. So the answer is 1. The answer is 1. Please see it again from the beginning. X to the power m upon x to the power n. What I have done is I will tell you about 1 and then everything will follow. X to the power m, I have taken x to the power n up. So it becomes x to the power minus n. Base is the same, powers get added. X to the power m minus n. Added, subtraction is also addition with a negative sign. So x to the power m minus n. Now it is m minus n to the power m plus n. So power into power gets multiplied. M minus 1, m minus n into m plus n will give you m square minus n square. Similarly, you will get here n square minus l square minus m square. Base is the same, powers get added, and all the powers will cancel with each other. One is m square, another is minus m square, n square minus n square, l square minus l square, and finally you get x to the power 0. Any non-zero number risen to power 0 is 1. That is why your answer is 1. Now let us see question number 11. He says a is equal to b to the power 2x, b is c to the power 2y, and c is a to the power 2z. He says prove that we have to prove x, y, z is equal to 1 upon 8. We have to prove x, y, z is 1 upon 8. So what are we going to do? Okay. A is b to the power 2x. It is given a is equal to b to the power 2x. But b is c to the power 2y. The value of b is what? C to the power 2y to the power 2x. Now, what is c? The value of c is a to the power 2z to the power 2y to the power 2x. That means it becomes what? Power to the power to the power. It will become 8 to the power a to the power 8x, y, z. I have taken 8 is equal to b to the power 2x. In place of b, I replace it with c to the power 2y, c to the power 2y to the power 2x. Then the value of c is a to the power 2z. So in place of c, I'll write a to the power 2z. So it is a to the power 2z to the power 2y to the power 2x. So power to the power gets multiplied with each other. We get a to the power x, y, z. And it is what? A to the power 1 it is. A to the power 1. So we have on an equation in which on both sides the bases are same, so powers can be equated. That will imply that 1 is equal to 8xyz, or it will imply 1 upon 8 is equal to xyz. That is what you wanted to prove. You wanted to prove that xyz is 1 upon 8, so we have got xyz as 1 upon 8. You can clearly see what we have done. It's very simple. A is equal to b to the power 2x. In place of b, put c to the power 2 by a. We replace b by c to the power 2y. Then we replace c by a to the power 2z. So we get a to the power 2z to the power 2y to the power 2x. 2 to the power a to the power 2z, 2y, 2x get multiplied. We get 8xyz. A to the power 1 is equal to 8 to the power 8xyz. Both side bases are same, powers can be equated. So 1 is equal to 8xyz, or 1 upon 8 will be xyz. That is what you have to prove. Now let us see the last question in this for today's video. That is, he says 1176 is equal to 2 to the power p, 3 to the power q, and 7 to the power n. First of all, we have to find out the value of PQR. We have to find the value of PQR. It is 1176. Let us find out the prime factors of 1176. How do we find? Like you used to do in HCF and LCM. 2 5s are 10, 2 8s are 16, 2 8s are 16. 2 5s are 10, 1 will be left 17, 2 8s are 16, 2 8s are 16. 2 2s are 4, 2 9s are 18, 2 4s are 8. 2 1s are 2, 2 4s are 8, 2 7s are 14. 3 4s are 12, 3 9s are 27. 7 7s are 49, 7 1s are 7. So you have got factors of this as 2 into 2 into 2 into 3 into 7 into 7 equal to 2 to the power p, 3 to the power q, 7 to the power r. You've got the prime factors of 1176 as 2 into 2 into 2 into 3 into 7 into 7, 2 to the power 3, 3 to the power 1, 7 to the power 2 is equal to 2 to the power p, 3 to the power q, and 7 to the power r. So I have got on both the side bases same, 2 3 7, 2 3 7 multiplied. So if I equate the powers, p, 2 has got power 3, 2 has got power p. So p is equal to 3. 3 has got power 1, 3 has got power 2. So q is 1 and r is 2. 7 to the power 2, 7 to the power r. So I've got the value of PQR, which is the first thing which I wanted to do. Find PQ and R. And then he wants you to find the value of 2 to the power P, 3 to the power Q, and 7 to the power minus R. He wants you to find the value of the following: 2 to the power P, 3 to the power Q, and 7 to the power minus R. So 2 to the power P means 2 to the power 3, 3 to the power 1, and 7 to the power minus 2. So 2 to the power 3 means 2 to the 4 to the 8, into 3 and 7 to the power 2 means 49. So it is 24 upon 49 is the value. 24 upon 49 is the value for this expression, which is 2 to the power p, 3 to the power q, 7 to the power minus r. Thank you.